Today's Fun Fact Friday is brought to you by the Plasma Science and Fusion Center at the Massachusetts Institute of Technology. The definition of plasma. Actually, today's Fun Fact Friday is the definition of plasma as I read it off of the Plasma Science and Fusion Center at the Massachusetts Institute of Technology. Plasma is superheated matter, so hot that the electrons are ripped away from the atoms, forming an ionized gas. It comprises over 99% of the visible universe. In the night sky, plasma glows in the form of stars, nebulas, and even the auroras that sometimes ripple above the north and south poles. That branch of lightning that cracks the sky is plasma. So are the neon signs along our city streets. And so is our sun, Sol, the star that makes life on Earth possible. Plasma is often called the fourth state of matter, along with solid, liquid, and gas. Just as liquid will boil, changing into a gas when energy is added, heating a gas will form a plasma, a soup of positively charged particles, or ions, and negatively charged particles, electrons. Because so much of the universe is made of plasma, its behavior and properties are of intense interest to scientists in many disciplines. Importantly, at the temperatures required for the goal of practical fusion energy, all matter is in the form of plasma. Researchers have used the properties of plasma as a charged gas to confine it within magnetic fields and heat it to temperatures hotter than the core of the sun. Other researchers pursue plasmas for making computer chips, rocket propulsion systems, cleaning the environment, destroying biological hazards, and healing wounds and other exciting applications. You didn't think you could get away that easy, did you? Today's Fun Fact Friday is brought to you by the ionosphere. The ionosphere is a layer of the Earth's atmosphere that contains a high concentration of ions and free electrons and is able to reflect radio waves. It lies above the mesosphere and extends about 50 to 600 miles, 80 to 1,000 kilometers above the Earth's surface. Before communication via satellites became common, the operators of radio communication systems often used the ionosphere to extend the range of their transmissions. Radio waves generally travel in straight lines, so unless a tall transmission tower can see the top of the receiver tower, the curvature of the Earth limits the range of radio transmissions to stations that are not over the horizon. However, some frequencies of radio waves bounce or reflect off the electrically charged particles in certain ionospheric layers. Pre-satellite radio communications often took advantage of this phenomenon, bouncing radio waves off of the sky to extend the range of the signals. Radio operators had to account for the constant changes in the ionosphere, particularly the shifts or disappearance of the layers between day and night, to effectively take advantage of these mirror-like reflections of radio waves.